Every number carries a quiet story. Some are simple, some are complex, and some reveal their beauty only when we look closely at their divisors. A few rare numbers stand apart, not defined by excess, not defined by scarcity, but by perfect balance. They have exactly four divisors, no more, no less. Welcome to this presentation on the problem titled Four Divisors. Let us begin by clearly understanding the problem. We are given an integer array called nums. For each number in this array, we need to determine whether it has exactly four positive divisors. If a number does have exactly four divisors, we compute the sum of those divisors. Finally, we return the total sum obtained from all such valid numbers in the array. If none of the numbers meet this condition, we simply return 0. Before solving the problem, it is important to recall what a divisor is. A divisor of a number n is any positive integer that divides n without leaving a remainder. For example, consider the number 21. Its divisors are 1, 3, 7, and 21. Since it has exactly 4 positive divisors, it qualifies for our problem. Most numbers do not satisfy this condition, which is why we must be selective. Let us walk through a simple input to make this concrete. Suppose the input array is 21, 4, 7. The number 21 has 4 divisors, so it is valid and contributes to the answer. The number 4 has only 3 divisors, so it is ignored. The number 7 has only 2 divisors, so it is also ignored. Therefore, the final result is the sum of divisors of 21, which equals 32. This problem becomes much easier once we understand a key mathematical observation. A number has exactly 4 divisors if and only if it satisfies one of the following conditions. First, it is the product of two distinct prime numbers, such as 21 equals 3 times 7. Second, it is the cube of a prime number, such as 8 equals 2 cubed. Any number that does not fall into one of these categories cannot have exactly 4 divisors. Using this insight, we can outline a clear approach. For each number in the array, we find its divisors efficiently. We immediately stop if the number of divisors exceeds 4. If the number has exactly 4 divisors, we add them to our total sum. This ensures both correctness and efficiency. Checking all numbers from 1 to n would be too slow. Instead, we use an important optimization. We only check divisors from 1 up to square root of n. Whenever I divides n, we know that both I and n divided by I are divisors. This reduces the time complexity significantly and keeps the solution fast. Now let us start building the C++ solution. We define the solution class and a function sum4divisors. We initialize a variable called total sum to store the final answer that we will return. Next, we iterate through each number in the input array. For every number, we create a temporary vector to store its divisors. This allows us to dynamically track how many divisors we have found so far. Inside this loop, we search for divisors efficiently. We iterate from 1 to the square root of the number. If I divides the number evenly, we add I as a divisor. If I is not equal to n divided by I, we also add the paired divisor. This ensures that all divisors are captured correctly. At this point, we apply an important optimization. If the number of divisors exceeds 4, we immediately stop checking. This early termination avoids unnecessary computation and improves performance. Once divisor detection is complete, we check if the count is exactly 4. Only in that case, we add all the divisors to total sum. After processing all numbers, we return the final accumulated sum as a result. Let us analyze the efficiency of this solution. For each number, we check divisors up to its square root, resulting in a time complexity of big of n cross square root m, where n is the array size and m is the maximum value. The space complexity is big of 1 since we only store a small list of divisors temporarily. To summarize, the key to this problem lies in understanding the mathematical structure of numbers with exactly 4 divisors. Using square root optimization and early termination makes the solution both fast and elegant. This approach is clean, efficient, and well suited for coding interviews. Thank you for your attention.